Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well and you are, I'll be honest, a lot of people take July 5th off. And I was almost guilty of that, but Ralph Bond is holding me true. But yeah, no, a lot of people take July 5th off, so I hope that you are having a relaxing, extended weekend to everyone out there. And for everyone out there who, has to be working this day, I hope it's an easy day and you are ready for some Computer America, because Ralph joins us every single Friday to talk about a number of different articles, and, that number is usually 4. They cover really, the gamut, everything from, everything that science and technology touches, and he has some very interesting ones. Especially story number 4 is going to be a lot of fun for fun for stroke victims, because hey, there's rehab is super important, and hey, stick around for story number 4. But hey, we still have to get through story 1, 2, and 3 to get to 4. And with that being said, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, really anything that we do here at Computer America, you can find on our website. And of course, the show notes are going to be super important, because Ralph puts a lot of effort into making sure that everything that we talk about is available in the show notes. So if you're simply listening, or you're driving, or you are busy, don't worry. You can come out to the website, check out all the show notes, and hey, we'll have links to videos and everything if you want to see it as well. So with that being said, let's go ahead, bring Ralph on, and just have fun with it. And Ralph, welcome back onto Computer America. He is, of course, our science and technology trends correspondent. And Ralph, how you been?
A gigantic backyard family and friends party yesterday celebrating the 4th, and I'm sure many of you out there are also recovering, but we're going to help boost your recovery with very positive news from the world of science and technology. So what Ben and I do every Friday, as he was mentioning in passing there, we look at everything: artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it, across the board. And what we do is we give you an oasis. I can't even say that. An oasis, a safe spot of positive news, thanks to the world of science and technology. So if you're looking for divisive, fractionalized, finger pointing, name calling, anger, no, that's not us. We do things that are going to leave you feeling like there is hope for mankind, for human beings, thanks to science and technology.
And I think you do a good job, because, it's not just the feeling of hope, but yeah, there is a lot of very cool new advanced research going on that,
Yes.
we love to highlight, and you do a great job of finding. So with that being said, I think story number 1 is a good example of, kind of future thinking and what's going to really help us out in the future. And Ralph, I think a lot of people know by now that generating electricity is, it's still the problem, because, hey, we always need more electricity, but storing electricity seems to be the biggest issue when it comes to, large facilities and the entire energy grid, just so on and so forth. Like, batteries are almost more important than just being able to generate power. So story number 1 really strikes to the heart of that, and hey, maybe even gives us a new solution. So
exactly, yeah, Ben. And in that world, one of the things that's so interesting is expanding your brain or your mind's idea of what is a battery. Because when we think of batteries, we think of the AA battery I put in my mouse or whatever, right, that kind of stuff, or the battery that's in my EV car and so on and so forth. But another way of thinking about batteries, and this is why story number 1 is so interesting to me, is the idea of storing energy that then can be used to create electricity. as opposed to a battery in the traditional sense that most of us would think of. So with that said, let's get into the story. The headline here is Energy Company launches world's first energy storage facility using molten salt. How can you resist that headline? I love it. And this comes from a very interesting outlet called The Cool Down, a strange name, but it's really a cool, well, no pun intended, cool reference or resource. So let's get into the story. They open up the article with, as we invest in solar and wind power infrastructure, it's vital that we also find ways to store the extra energy these technologies generate, so we can make clean electricity more efficient, thereby driving down energy costs for homeowners and industries alike. So a Danish energy company called Hyme, Hyme Energy, is launching a new energy system they call molten salt storage, which uses molten hydroxide salt to store excess clean energy. And it's the first project of its kind. A little side note here, and this is what we do in the show notes. Ben mentioned this. Come out to computeramerica.com. The show notes for today's show will have links, additional information that I inject to augment these articles and so on. So please check that out. So what is hydroxide salt? It consists of an oxygen and hydrogen atom held together by a single covalent bond carrying a negative electric charge. And sodium hydroxide is a widely used industrial alkali that is often found in drain and oven cleaners. So ever use one of those drain cleaners or oven cleaners, you've been using sodium hydroxide. So back to the story, Hyme Energy developed the system to utilize excess energy from solar or wind power to heat hydroxide salt, melting it into a molten substance at super hot temperatures. And I'm going to stop for a second. What we're talking about here, folks, is if you're lucky, if it's a good, very windy day and those windmills are just spinning like crazy and generating a whole bunch of electricity, but more electricity than can be stored conventionally, the challenge is how can we take that excess energy from solar or wind and hold on to it,
Right.
transform it so it can be used later to create electricity. So that's what we're talking about. It's very, very cool. So the molten salt is then stored at high temperature and saved for a rainy day. That's what I was alluding to a moment ago. Once there's a period of lower clean wind or solar energy generation, so when you have a doldrums day for the windmills or you have a cloudy day for the solar, the facility can unleash its stored salty heat as thermal energy that is converted into steam, which can provide electricity. So, Ben, that goes back to my request that everyone start rethinking or expanding their definition of what is a battery. That's what we're talking about here, which I think is really cool.
For sure.
And that Hyme Energy hopes to scale their molten salt storage technology globally for industrial purposes and have it ready for sale in 2026. So we're getting a little sneak peek here. That's part of the trends of what we do every Friday. Now, this is fun. The article mentions in passing, and this will go back to a show we did on the 17th of May, and I'll get to that in a second here. So other new developments in clean energy storage, that is storage for excess production of solar or wind power. So other new developments in clean energy storage are using ice, which is very curious, mines, as in like coal mines and whatever, and even chicken fat. What? And even chicken fat to store extra clean energy. Now, time out, you might remember this one. This was one of our honorable mention news items for back in May 17 show. And real quick in passing, I just have to refresh on this because it's such a wacky, crazy thing. But researchers in South Korea have made an intriguing breakthrough by converting chicken fat into energy storage devices. They've developed a method to transform chicken fat into carbon-based electrodes and supercapacitors, which can store energy and power LEDs. And the show notes, if I could say that, the show notes have a link to that story if you want to refresh on that. But it's a very interesting world. Again, rethink your definition of a battery. Think about how do we deal with excess production of wind and solar and hold on to it so we can use it on a quote unquote rainy day.
No. And really, like, it's a great idea for a battery, and you know the diagrams, like, it's very well thought out, and I think one of the best parts of it is, I guess, kind of the scale of it, because It can go,
Yeah.
big, 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 big. Like it can store a lot of energy for that rainy day. Reminds me a lot of the, just this one heating up salt to then, kind of discharge the steam. Ralph, it reminds me of the other one, and I think you alluded to it by saying other new developments include mines. The one with the physical counterweight that they would use the excess electricity to raise a giant, just like a giant rock essentially, and then whenever they need electricity, it would, they would lower the rock, and just the force of gravity would generate electricity. Little things like that, Ralph. Just
I know.
Just utilizing, in that case, it was like mines that were no longer feasible or usable, using them as a battery. All these are just parts of a big solution that, there is hope that we can get energy under control. So.
Yeah. And Ben, I want to refresh something you and I have talked about many times in the past. What's so encouraging about this kind of news is it's not just one thing that's going to solve our climate change alternative to fossil fuels challenge, right? It's not one thing. But if you think about the combination things from chicken fat to mines to ice to this new battery technology, on and on and on, all these things come together as a conglomerate to solve our problems. And so that's what I find so exciting and so encouraging.
Molten salt, mines, chicken fat, you name it. There is a use for it. And hey, that's just the name of the game, just using what we thought was waste. So there you go. Story number one. Story number two. And we're going to go ahead and go down and talk about 3D printer. And, we've talked about a lot of different kinds of 3D printers. But one thing that has tied so many 3D printers together is that generally they extrude like one thing, like they're plastic, they're biocells, they're this, they're that.
Yeah.
You found one that, has a different kind of method so that it can do multiple materials. And that's a pretty big breakthrough.
It is. This one comes from Science Daily, and the source is the University of Missouri. So here we have something from the United States, which is wonderful. And the headline here, this is in the world of 3D printing, this is a biggie, okay? Headline: first ever 3D printer that gulps plastic, metal, and semiconductor chips to make layered devices. Subhead: innovative 3D printing method streamlines multi-materials manufacturing. Wow. I mean, stand by. This is really great. We've got a whole bunch of links here for you, all the technical articles and so on and so forth. But here's the story. University of Missouri researchers have developed a way to create complex devices with multiple input materials, including plastics, metals, and semiconductors, all, here's the key, with a single machine. This is really something. The research, which was recently published in Nature Communications, outlines a novel 3D printing and laser process to manufacture multi-material, multi-layered sensors, circuit boards, and even textiles with electronic components. It's an incredibly versatile thing. It's called the Freeform Multi-Material Assembly Process, and it promises to revolutionize the fabrication of new products. And here the author gives a little humanizing. What could this mean for you and me? Well, for the public, applications could include, and not exclusively, but could include things like wearable devices that monitor blood pressure and other vital signs. So that's just one little example. To date, and here's the key, to date, other 3D printing techniques have fallen short when it comes to how versatile the input material can be. To your point a moment ago, Ben, you said usually we think of a 3D printer using some kind of plastic filament or something like that, and or in architecture, concrete, big giant 3D printers and so on, but just one material at a time, right? So most of these techniques to date have fallen short when it comes to how versatile the input material can be and how precisely smaller components can be placed inside larger 3D structures. So we're not only talking about printing something like the wall of a building, but how can I print something that goes inside? And I shouldn't have used the architecture example because we're really talking about smaller scale stuff in this story. So the University of Missouri's team method uses special techniques to solve these problems. Team members built a single 3D printing machine that has 3 different nozzles. One First one adds ink-like material, very traditional. Another uses a laser to carve shapes and materials. So that's reductive, not additive. So it's a kind of hybrid, if you will. And the third nozzle adds additional functional materials to enhance the product's capabilities. So again, Ben, it is a hybrid because there's additive and reductive with the laser. So
Right.
to be honest and fair, it is a hybrid, but I think a fascinating solution. And then the article talks about, well, how does this work? It starts by making a basic structure with regular 3D printing filament, such as polycarbonate, a type of transparent thermoplastic, which you alluded to earlier in your first comments about this story. And then the device switches to the laser to convert some parts into a special material called laser-induced graphene. So it is an additive as well as reductive, putting it exactly where it's needed. And then finally, more materials are added to enhance the functional abilities of the final product. And folks, this is a good example of, wait a minute, all of this is like hitting my head so fast. What's going on? Come out, get the show notes, go and read the papers, read the other supportive articles and references if you want to geek out and really fully understand that what Ben and I are doing is just skipping a stone over the water to give you the highlights. There's so much more underneath all of this technology that you could learn if you want to really super geek out. If you're a 3D printing addict, this story is for you.
Yeah, no, and just, even seeing this one image that's up on the screen right now,
Yes,
you can really get an idea of, the entirety of it is made with a 3D printer, and then the lines, the trenches, the places that you would put the wiring or, whatever you would put in it are already there, ready to go. And hopefully an all-in-one process, like you said, is what the, is what this leads to. So.
Yeah, and one final note, Ben, by the way, all this research in Missouri is being funded by the National Science Foundation Advanced Manufacturing Program. So this has really gotten some serious attention.
Yeah, for sure. And really just, it seems like, Ralph, they are really pushing this towards, I'm sure, a lot of different areas, but it seems like chip manufacturing, it seems like a very, very obvious one. Like, I know that they're using chips, but, to, kind of integrate those into products makes more sense. Anyways, all that great stuff, and makes sense that the National Science Foundation for Advanced Manufacturing would, kind of fund that. So, perfect. Story number 2. And again, like you said in the show notes, story number, and there's a great video, by the way, in the MSN article that you linked that showed, a lot of great 3D printing and how it's changing food of all things as well.
Oh, gosh.
So there you go.
It's a wonderful world there.
For sure. So, story number 2, story number 3. And this is, you have an affinity for construction.
Yeah. Yes.
Which for longtime listeners should be no surprise. But, here's something that I really didn't think about, which is, kind of, I guess, flooring for, kind of for multi-story buildings. It's one of those things that's like, it's not my job to know, but also I had no idea that was someone's job. It's a very kind of niche story, but still very cool. So story number 3.
Yeah, story number 3, and what Ben's alluding to is that I spent the last 10 years of my active career in high tech before semi-retiring, if you will, with Autodesk. And in Autodesk, it was all about building information modeling, software technology, and helping the whole construction industry move forward. So that's why this story really appealed to me. And I'm going to give you the headline, but I did doctor the headline a little bit to make it, I think, a little more explanatory. So researchers make green modular floor to replace steel in multi-story buildings. Excuse me. And this comes from the Oak Ridge National Laboratory news outlet. And if you're watching the video, you're seeing the picture from the show notes. That's very helpful. But if you're just listening to us as a podcast, let me try to give a verbal description. In today's multi-story architecture or construction industry, not always, but a lot of times they're building modules off-site, bringing them to the construction site, and the picture shows a huge crane lifting a modular unit with a floor all pre-made somewhere else up in and then installed into the building, sort of like think of it like super sophisticated Legos. Okay. So with that kind of visual thing in mind, let's get into the story. excuse me, researchers at the Department of Energy's Oak Ridge National Laboratory and the University of Maine have designed a 3D printed single piece recyclable natural material floor panel tested to be strong enough to replace construction materials like steel. Now let that sink in for a second. Recyclable natural material floor panel tested to be strong enough to replace construction materials like steel. And
Impressive.
the team called, yeah, well, and it's very profound. It's so great in the world of construction, more and more and more recyclable materials being incorporated instead of having to use fossil fuel intense things like steel production and so on. But we'll get into that in a moment here. So the team calls this floor panel they've created N, as in like Nancy, N floor run together, N floor cassette panel. That's what they call this innovation. So the goal, as we mentioned before, is to replace traditional steel and concrete floor surface assemblies in multi-story buildings that, I'll add on, are constructed using off-site fabricated modules that are brought on-site and popped together like Legos. So the project is part of the Sustainable Materials and Manufacturing Alliance for Renewable Technologies. And the acronym, of course, you have to have that, is SM2ART or SM2ART program. And the SM2ART team previously constructed BioHome 3D, the nation's first additively manufactured home made entirely from biologically based materials. And by the way, Ben, you may recall, if you're looking at the show notes, folks, you may recognize this building. We talked about it months ago when it first came out as a highlight in a story. It's very interesting.
Yeah.
And as mentioned before, the SMT Art end floor cassette panel was developed to replace traditional steel and concrete surface assemblies as a transformative step for constructing apartment and condominium buildings. That's the main target here. And the SM2 Art end floor cassette sturdiness, oh, you're going to love this, comes from its unique formulation of polylactic acid, or PLA, which is a biodegradable thermoplastic polyester bioplastic derived from corn residue and wood flour made from the waste of lumber processing. By the way, wood flour, I believe I'm correct on this, wood flour is a fancy way of saying sawdust,
right.
Real fine sawdust. So gotta love it, corn residue and sawdust. Yay! The technology has the potential to create strong, biologically based sections that could make multi-story buildings more environmentally friendly. It could also help increase the use of sustainable structures that are made in a modular construction facility. That's the bit about off-site construction. So the Oak Ridge National Laboratory researcher Katie Copenhaver said this first effort to make a strong building floor panel from green resources significantly advances the potential for increasing the use of organic materials in modular multi-residential buildings. Wow. And she goes on to say, quote, by utilizing bio-based large-scale 3D printing, we replaced an assembly made from 31 parts and 3 materials with a single material floor panel that is ecologically friendly and with the same strength as traditional steel floor fabrication. Wow. I mean, this is just so great. And I'm going to get into a little bit of how this was done. How do they make this thing? To construct the floor panel, researchers used a large scale 3D printer, there's good old 3D printing again, to deposit the PLA/wood flour mixture in a precise geometric shape. By working continuously and autonomously, the printer produced the SM2 Art end floor cassette at scale, layer upon layer, in about 30 hours. And that may sound like a lot, and you think, oh, well, is that economically viable? Well, here you go. The process created a labor savings of about 33% compared to the effort needed to construct a similar steel floor assembly by hand.
There's always kind of those tidbits where it's like it saves time, labor, money, and they obviously they want to play that up, and they should. That's very important in construction. But Ralph, it's always like, I don't know, trying to get people on board. I'm sure to, because they've been making these buildings these ways for, decades and decades,
right.
I'm sure almost a century by now. Getting someone to do something different and new. If you're, shelling out the money for a skyscraper, how likely are you to kind of get them to jump over? Which, again, they should. And this technology needs to be tested. And it looks like they're putting it in. So someone's taking the chance. But it sometimes it's hard to get people to, try something different.
Right. Yeah, exactly right. And by the way, in the show notes, this is optional. I'm not going to go through this because it's a lot of information, but I did insert some background on this SM2 ART or SM2 ART program, and you can go to the show notes and learn all of it. Fascinating, really fascinating.
For sure. Yeah, and I love hearing from these guys because they're not, and trying to find their website, Ralph, usually it's like some kind of private entity, you kind of do that thing. Instead, you get the Oak Ridge National Laboratory, and then if you kind of go through, you can visit SM2 Art, and it takes you to the University of Maine. So this is a nice collaboration between
it's wonderful.
Yeah, a university and an organization that's purely for kind of research, and it's great. It really is a great partnership, and love to hear more from. Love to hear Ralph, where like people have had successes and do something new, which like that house, for instance, and then they continue and say, we can apply this to other areas of construction. Right. In your professional opinion, before we move on to story number 4, these kinds of things, and surprise, the first additively manufactured house built in 2021 using sustainable material, a lot of qualifiers in there. But Ralph, people are dealing with kind of like a housing crisis. I don't know if you've heard about that. Not to bring reality too much into this, but do you kind of have hope for the future? Like, you've dealt with construction. I know you dealt more like the commercial side, but like building houses is getting easier, right? Like people are going to have houses in the future. One can hope.
Yeah. Oh, you're absolutely correct. One of the things that's going on in the construction industry in terms of trends is more and more and more attention to prefabbing things and then transporting either modules or entire structures to the site, to the location. And so a little sub-example, there's, of course, the terrible problem of homelessness across the country. And here in Oregon, we're wrestling with it like everybody else. But one of the things that's happening a lot is creating these environments where you have multiple modular little tiny home or tiny...
Yeah, I've seen those.
Living quarter modules that are all self-contained. They're fabricated off-site, everything including the AC, everything built into the little module building or structure and then brought on site. And so you're going to see more and more and more of that. The story we just did, if you're again looking at the show notes, if you're looking at the video, you can see the little idea of modular stuff created in a factory, then brought on site and put into place again like giant Legos. So I think you're just going to see more and more and more of that.
And I'm sure it's much more, not just environmentally conscious, but economically. I'm sure it's way cheaper. And I'm sure, especially for the homeless population, like you were saying,
right.
You really don't need more than to kind of get started on your way to recovery than just somewhere safe to sleep and somewhere kind of safe to stay. So a lot of hope there and a lot of progress being made there. So there you go. Story number 3. Story number 4. Let's go ahead and talk about this. And I kind of tease it a little bit way at the beginning.
Yeah.
And the images are just so strange, and I don't know why they decided to use like kind of like a toy gun, but the images are very, very strange. How they are repurposing a gaming device to help stroke patients, and obviously there's a lot more to that. Ralph's going to get into that, but obviously, stroke is kind of near and dear to Computer America's heart because Craig he had a rushed retirement due to stroke a couple of years ago. So it's it can happen to anyone, anywhere, anytime. Know the signs, and he's doing well. For everyone out there who's asking, just the other Ralph, I still get emails like every I wouldn't say every day, but every week, from PR reps and from people that we used to be in contact with him over the years, and they're like, hey, how's Greg? Where's he been? It's, a lot of people have reached out and said hi to him, but either way, okay, long story short, strokes suck. And recovering from stroke is really, really hard, but totally possible, and something that just needs more research, time, and effort. And story number 4 lends to that. So
exactly right. Yeah, and this is a great story from MedicalXpress, a great outlet as well. And the story source is NYU Tandon School of Engineering. But here's the headline, and I did also doctor up this headline to make it a little more explanatory. Headline: researchers repurpose a video gaming device to develop technology that may allow stroke patients to undergo rehabilitation at home. So there's lots of layers to this story, all good layers. And so let's get into it here. And if you're looking at the video, you have the advantage of seeing what this device is. And it's this curious kind of tabletop thing. It's like a cone with these little arms. And in a first-person shooter game, you would insert a gaming pistol, if you will, and you move this thing around. And what it does is it moves you around in the game in a very easy and intuitive way. You can see videos of this device in action.
I'm pretty, kind of tuned in, especially to the gaming side of technology. Yeah. This device is not something that I've ever seen before.
Neither have I. Yeah,
this is a very kind of niche product. Like, Ralph, you can imagine people that, build like the entire like driving simulators in their house, and they have they have the monitors and whatnot, and the chair. I think this is for the same thing. People who want like a really accurate kind of like maybe like hunting simulator or something like that. This is a very unique gaming device. It's not just like a joystick and controller. So
no, it is. It's fascinating, actually. And like you, I had never seen or heard of this product before. Not that I'm a gaming guy, but it still just intrigued me. So once again, friends, if you're listening to us as a podcast, come out to computeramerica.com. Get the show so you can see the picture of this device and see the videos and all this good stuff. It's very, very interesting. So anyway, let's get into the story. For survivors of strokes, which afflict nearly 800,000 Americans each year, yikes, regaining fine motor skills like writing and using utensils is critical for recovering independence and quality of life. But here's the problem. But getting intensive, frequent rehabilitation therapy can be challenging and, of course, expensive. That's the problem that these researchers said, what can we do to help? Well, now researchers at NYU Tandon School of Engineering are developing a new technology that could allow stroke patients to undergo rehabilitation exercises at home by tracking their wrist movements through a simple setup. The combination of a smartphone strapped to the forearm and a low-cost gaming controller called Novit Falcon. That's the device we were trying to describe with words only. So that's Novint, separate word Falcon, like the bird. Novit Falcon. Really interesting. So the Novit Falcon is a desktop device typically used in video games, and it can guide users through specific arm motions and track the trajectory of its controller, but it cannot directly measure the angle of the user's wrist, which is essential data for therapists providing remote rehabilitation. So this device can do one thing very, very well, but it can't do the angle of the wrist. So how do we solve that problem? Well, the researchers all explain. In a paper published in Soft Mechatronics and Wearable Systems publication, the NYU researchers proposed using the Falcon video gaming device in tandem with a smartphone's built-in motion sensors. Wow. Two existing things, put them together to precisely monitor wrist angles during rehabilitation exercises. How clever is that?
By the way, I went through the link that you provided in the show notes. I am surprised. Like the hardware reviews from Ars Technica, love Ars Technica. They're a great publication.
Yes.
The reviews from 2008. Like this is like a 16-year-old article about this device. So this thing's been around for a little bit.
Yes. Yeah. The Novit Falcon has been around for a long time, and somebody in the NYU team said, "Wait a minute, that thing does this really good. And the smartphone has the motion sensors. So wait a minute, maybe we can combine these. I always love it when someone has that aha moment.
and especially utilizing older technology to
Yes.
do something very precise. That's cool. That's cool.
Yeah, very cool. So the researchers collected data from a healthy subject performing tasks with a falcon while wearing motion sensors on the forearm and hand to capture true wrist angle. They then trained an algorithm to predict the wrist angles based on the sensor data and the falcon controller movements. The resulting algorithm could predict wrist angles with over 90% accuracy, a promising initial step toward enabling remote therapy with real-time feedback in the absence of an in-person therapist. I want to stress something that's kind of an underpinning thing of many of our stories span every week, is this is initial research.
Mm-hmm.
They're saying this looks promising. They're not saying it's done deal, but they're very excited about their experiments that this might help enable remote therapy. So Ronnie Barak Ventura, the paper's lead author, noted, quote, this technology could allow patients to undergo rehabilitation exercises at home while providing detailed data to therapists remotely assessing their progress. It's a low-cost, user-friendly approach to increasing access to crucial post-stroke care. Ta-da! I love it.
I do too. Although I am curious, where do you buy these things? I'm curious if like they're still making them themselves, if they're only using like old products. Like, I don't know, do they still make new ones, Ralph, or are they?
I think if you do a Google or a search on Novit Falcon, I'm pretty sure it's still available for sale.
I did that, and I think they're only selling old ones. They're not making any new ones, and of course, from like third-party sellers and stuff like that. Huh. So I think the university obviously has a supply of them to kind of do this. Kind of makes me think that this is like, much like the Xbox Kinect, which if people out there don't know, the Xbox Kinect was one of the best things to happen to universities. It was a widely disseminated, easy to acquire visual camera with like multiple 3D imaging and stuff like that.
Yep.
That universities all over the country were able to use and utilize to great effect for their research. Like the Xbox Kinect controller was great for research. And I think this is going to be the same thing. It's just, they're going to have to use this as a starting point and then probably develop a device that isn't from, 15 years ago. So, for other people.
Well, maybe they can recreate it. In other words, if this has promise, even if this product no longer exists in terms of being produced, maybe they can get
it's something to start with.
And they could create their own version of it or something. So again, that's an interesting challenge. We'll see where it goes.
Very, and again, it kind of goes to the point of I don't remember this thing. It's because it's from so long ago. But I'm glad someone remembered it and found a very cool use for it. So there you go. Story number 4. Ladies and gentlemen, that's our 4 stories for today. Although, if you are following along in the show notes, you may notice it doesn't end there. That's right. The fun continues. And we have a section here called honorable mentions, as we always say. It's they're not worse, they're not less, they're not, it's not that they're not interesting. It's more so that we try to keep things concise and, kind of in a timely manner for you. Yeah. But Ralph, for the nice folks out there, if they go out and find those, let's at least give them the headlines that if you come out to computeramerica.com, you can find it right there in the show notes.
You got it. So quick little grab bag of a few fun stories to check out if you want to dig deeper. Headline, a big boost for climate solution, electricity made from the heat of the earth. Not a new concept, but an interesting recent development comes from the Associated Press. So check that out. That's kind of fun. Next one, Intel says its optical interconnect chiplet technology is a milestone in high-speed data transmission. And this comes from techspot.com. Interesting, geeky stuff if you want to check that out. And then the next one is electric car battery charges in under 5 minutes in track test. This comes from the British BBC from Great Britain. Wow, that's pretty interesting.
I know.
And then another one here, I think our final one is revolutionizing medical implants with soft robotics. Again, not something that's unique, we've never heard of before, but another advancement. The source here is an outlet called AZO Robotics. So check out those stories. They're really fun. Additional homework for you.
Absolutely. Yeah. And ladies and gentlemen, of course, those will be down there. And if you want to find out anything else about any of the stories that we did, you can, of course, go to computeramerica.com, and Ralph has put all the links, all the sources, everything that you need to, make sure that we're being honest and we're not just making these up, which honestly would be harder to do because reality is stranger than fiction. And all of these have been something to kind of lead you into a Friday feeling happy, hopeful, and hey, cheery. Everyone, have a great weekend. I hope that you do something fun, and we will be back next week. Everyone, thank you so much. Catch you next time, computeramerica.com. Thank you, Ralph. Thank you, everyone. Bye now.